Hi, my name is Chris Aben, and today I'm going to be presenting the virtual environment that I created for my desktop virtualization class at WGU. To get started, I'm going to cover the problem statement, and then we'll get into the virtual lab so we can go over the steps that I took to get the network configured. SparkKit Company needs to leverage the power of virtualization in order to extend their ability to develop products for new platforms and ecosystems. The virtualized network will provide a sandboxed environment for troubleshooting any issues that arise with the interaction of the game source code with the native OS. Our proposed solution is to purchase a high-end multi-core CPU with 16 to 32 gigabytes of RAM, a high bandwidth network card, and the Windows 10 OS for the host machine. I will be building our virtualized solution with the Type 1 hypervisor known as Hyper-V. So to segue off that, to get Hyper-V installed, we had to use Windows features. So we essentially put a check next to Hyper-V and the related files and folders. We clicked OK. We restarted the computer to allow the update to solidify, and from there we were able to work with our virtualized hypervisor. So we'll start with our virtual switch manager. We use this to create the switches for our Net East and our Net West subnets. And the process was simple. We created a new virtual switch. We created a private switch. And then from there, it created the container where we could specify the name, and then we could point it to the specific connection type. For those local networks, we just kept them as default networks, and then obviously the default switch is connected to the internal network. Now for the process we followed for creating each respective virtual machine. In the Windows 10 Administrative Console, we would right-click and we would go to New, and then we'd create New Virtual Machine. Going through the wizard, we would specify the host name as the name for each VM, and then we would store the virtual machine in a different location. And we ended up storing this on our Z drive, which contained over 250 gigs of space, so that allowed us to stay within the criteria outlined in the requirement template. So as you can see, we've got our C drive, which has a lot of the Windows 10 host files. Our D drive is where our ISO files are, and then the Z drive, again, is where the VMs were stored. So we just defaulted to generation 1 for the virtual machine type. For the memory allocation, we unchecked dynamic memory, which was required. We were supposed to have a static RAM assignment. And for default, we just kept 1 gig of RAM for each system, and we figured that we can adjust this after effect depending on what type of work needs to be completed within the virtual environment. Through the wizard, you can also connect the guest virtual machine to its respective switch. So that would be Net East, Net West, depending on which subnet the device was on. And then from here, we would create a new virtual disk. Again, we would browse to our Z drive location, and then we could change our hard drive space. And we would allocate more hard drive space for the operating systems that are a bit more graphically intensive, such as Windows 10 or the Ubuntu operating system. So on this installation options menu, we're able to select our specific ISO. So we browse to that folder location, and then these were the different ISO files that we could work with. Once the wizard is complete, it would create a container here, and when you started the virtual machine, you would go through the installation of the ISO, and from there create user accounts. Additionally, if settings needed to be adjusted after the fact, you can right click on the container, get into settings, Like for starters, this is how we were able to add our additional SCSI controller to each one of our machines. It was required that we have 5 gigabytes of additional storage. As you can see, once we added a new SCSI controller up here, it created a new entry, and from here we were able to add a new hard drive and then go through that process. I'll avoid creating another hard drive just so as not to confuse myself, but this is where we were able to select the location for that drive, and when we go into each system, we can show how we actually mounted that in the space allocation. So I'm going to remove the one that we just had created, and then going on, here's our settings. I think we went over memory, so here it is for processor. So our system, we had 2 CPU cores, and we were only supposed to allow the virtual network to consume 50% of resources. So in order for the math to check out, we essentially allocated 40% of the total amount of resources for our CPU cores in order to try to stay within that threshold. And we'll demonstrate that when we do our testing using the resource monitor on the Windows 10 system. So the settings display here is going to be consistent no matter the version of operating system that the virtual machine is running. So at this point, we're just going to get into each one of these VMs, and we'll validate our network configuration, and we're going to validate our SCSI drive, and then we can start going through the testing sequence. Alright, so right off the bat, disk management is still open from when we did the configuration, but essentially before we initialized the disk, this was just a grayed out container, unable to write any files or data to it. So we right clicked and then we initialized the volume, and then from there we created a primary partition, and we were able to allocate the size of the disk to 5 gigs in the NTFS file system. Looks like the VM was in a shutting down state, so as soon as I'm able to get signed back in, we'll validate the IP address configuration. And while this is loading, I just want to take note over here to the action menu. This was really convenient for us in order to manipulate settings for each specific VM and also make settings that apply to the whole workspace here. Just a FYI. Okay, now that we're loaded here, we'll wait for our network to load, and then we'll be able to validate our Class B IP addressing. Alright, and this is where we were able to input the IP address profile for both Client A and Client B Windows 10 machines. So we'll keep this system loaded for now for when we do our networking test. But in the meantime, we're going to now move over to our Ubuntu system to show you the steps that we needed to follow in order to get this configured. And just right off the top, this was a very similar process to the Windows 10 machine, since there are a lot of graphical user interfaces that can be utilized to add networking and mount disks. So we're going to get started here. We're going to get signed in here. And then clicking the settings dialog is going to open up the network configuration wizard, and from here we were actually able to edit the fields to get our network configured accordingly. So we'll close out of this, and now we're going to navigate over to our disks application, and that's how we were able to mount the disk and get an active file system on it, so we could actually write to it and configure the size of 5 gigabytes per the requirements. And as you can see, here is our 5 gigabyte hard drive as outlined. So again, we're going to keep this system up and running for when we do our network test, but we're going to move on to our router. And as you can see, we already have our interfaces assigned to a label, either HN2, HN0, HN1. Unfortunately, I'm unable to point with the mouse since we're working with the shell interface here. And each interface has the network configured with the Class B network. So essentially, when we first got the firewall pfSense loaded, we clicked option 1 to assign interfaces, and then it asked us a series of other questions. Because we're already set up, I'm not going to go too deep to avoid creating any problems, but Option 1 would assign interfaces. Option 2 allowed us to set the interface IP address. So that was obviously done on the interfaces for the router connecting to each one of those local switches. And then again, we're going to keep this open so we can validate that we can ping from the router to those devices. So going forward, we're going to go into our CentOS machine. This one was the most, I guess, challenging to configure because we had to actually go into a configuration file in order to get the proper network address, network mask configured in the default gateway. And then we also had to run a few commands to get the drive mounted here. So I'm going to go through my history of commands. So this was the file that we accessed in order to edit the IP address information. As you can see, we've got our IP, our prefix, and our gateway right here. So we'll quit out of that. And then this is the folder where we can see our available disks. And as you can see, our SCSI drive is showing up there, which has an XFS file system. And those commands that were used are included in the design template that will also get submitted with this video. Alright, so now that we've gone through each one of our virtual machines and have witnessed the general configuration, we'll start to do the testing. So we're going to get right back into our router and we're going to ping each one of our interfaces. I'm going to actually get out of this just to avoid configuring over work that I've already done. I'm just going to reset and then we'll log back in there and then we'll start sending out some ping requests. Alright, so we can actually use option 7 to ping our hosts, and we'll just go through the list to make sure that everything is configured properly in that regard. So we're going to start with our CentOS machine. And I made an error there. I am used to typing the ping command, whereas in this context I actually just need to include the IP address. So as you can see, we're pinging successfully to our CentOS 1, which is located on NetWest. So we're going to keep going through. We'll stick with our NetWest, and we're going to now ping client A. Looks like we're getting success pinging there. Now we'll focus on our NetEast host devices. So again, we'll use option 7 to ping host, and then we'll type in the address for the Ubuntu system. And we're getting successful replies there. Again, option 7. This is our client B, our Windows machine. So we're pinging everything from the router, and then just to make sure that we can ping between each host in those respective subnets, we'll get into first our client A, which is on our NetWest network, and we'll ping over to our CentOS 1 machine. We're getting a successful connection there. So most likely, if we're in the CentOS machine, it's going to connect just the same. So to avoid redundancy, we'll just go into our other Net East computer, and we'll ping over to our Ubuntu system. So again, we'll get into command. Alright, and it looks like we're successful with pinging our other host machine on this subnet. And just to validate, we're on client B right there. So that is our first testing criteria to show that we had successful networking configured. We just proposed being able to send successful ping requests between each virtual machine. So now what I'm going to do is I'm going to turn off each one of these machines, and we're going to monitor the application called the Resource Monitor, and we're going to make sure that it meets the criteria that was set forth for the memory and for the CPU utilization. So currently everything should be shut down here within our virtual environment. We'll just confirm that. Looks like there's a couple instances running. And now if we open up Resource Monitor, just make sure that we've got one instance running of this. So as you can see, even with all of the virtual machines shut down, the fact that we're still working on a host machine that's running Windows 10, it's still using CPU and other resources. So keep that in mind for when we turn back on all of our virtual machines, because we'll have to factor out this additional CPU usage that is just inherently there from our host machine. So we're going to start by turning on each one of our virtual machines. And then now if we go back to our resource monitor, we'll wait for all the VMs to load up, and then they should all start to kind of solidify in terms of the processing. Alright, so now everything finally went through the initial loading, ran updates, and then now if we come back to our resource monitor, we can see how the CPU, it's finally resolved itself. Again, our host machine is contributing to this total amount, but this does a good job of dialing down back to 50% and below for at least the virtual network, which meets the criteria that was outlined from this assignment. Obviously, it's going to fluctuate, especially using systems like Windows 10 and Ubuntu that have a lot of graphical user interfaces and underlying services, but for the most part, that will keep us within the criteria. Now, when we look over at the memory, same thing here. Our host machine used some of that memory. The criteria was that we didn't use 60% of the physical memory, and we're at a good point right there at 65%. Obviously, if certain operating systems need to be worked on more, the memory settings can be allocated as such within the Hyper-V. And then when we take a look at our disk storage, we can see that we're well in the criteria outlined since we're only using 54.9 gigs of 250. And if we can do the math here really quick, we'll be able to get a percentage. So 54.9 divided by 250. So about 22% is what we are allocating for storage space. But nonetheless, I appreciate you taking the time to review my assignment. Again, we laid out the problem statement, we went over the general configuration for each VM, and then we covered the testing scenarios that we used for this assignment. Thank you.